All right. Welcome back to Mr. Jeffrey's Algebra 2 stuff. First off, want to thank all my subscribers, all 50 plus of them. We got to get those numbers up. If you haven't subscribed, go ahead and hit subscribe, hit the like button, hit the bell, all that kind of good stuff. All right. So now here it comes with factoring polynomials. So here's the deal. Back when y'all had Algebra 1, we would say, okay, today we're going to factor by the GCF. Today we're going to factor by shortcut. Today we're going to do AC bus to B. Now that you're in Algebra 2, it's basically you have multiple different ways to factor, and you've got to decide which one's going to work each time. Okay? Now, as it says, because I know even if you have your handout for the day, you probably didn't read this because they're directions and they might be important and people don't. It says sometimes we use a GCF, greatest common factor, the shortcut method, AC bus to B, or a combination of all of it. Okay, so let's look at A. So usually when there's two terms and those exponents are not even, we know we're going to factor by GCF. Okay, what is the biggest number that I can divide out of 3 and 48? 3. Very good. Okay, now remember, with your exponents, it's the smallest exponent between both of them. So which one's smaller, 5 or 3? 3. Okay, now we write the GCF out here, and then we actually do the division part. So 3 divided by 3 is 1. We have 5y's. We take 3 away, so now we have 2. So this becomes y squared. Okay, now we have 48 divided by 3, which is 16, and the y's cancel. Now, here's where the new stuff really comes about. The new stuff comes about with this word right here. You keep going till you can't factor anymore by using any of the methods we have. All right? There's something that we should notice right after we take out this GCF. Can we factor this anymore? Somebody said probably because I'm asking the question. Okay? Well, think about it. There's y squared and 16. These are both squared terms. This is a difference of 2 squares. No, we just leave the 3y outside. So, what is the square root of y squared? Plus goes here, minus goes here. What's the square root of 16? 4. That was somebody just kicked the chair. That was kind of aggressive. Okay. All right. Now, this is our final answer. We have factored it completely. Okay. Now, yeah, that wasn't so bad. Yes. Okay, so this was y to the 5th divided by y to the 3rd. Remember, when it's dividing, we subtract. So what's 5 minus 3? 2. So that's how that became y squared. Okay. All right. Now, so here's the thing on this. You kind of have to look at these. You do a step, and then you step back and look to see if there's anything else you can do. Okay. And here's the bad thing about that. Sometimes you won't see it at the first glance. Sometimes you have to look at it a little bit longer. It all depends on how you're wired and how you operate. Okay. Now, let's look at number B. Now, we have 3 terms. This is a trinomial. This is when we would normally do shortcut or the AC bus to B. But what do we notice about this exponent right here? It is the greatest. It's a what? It's a 3. You can't do shortcut. You can't do the shortcut if that's a 3. That only works if that exponent's 2. But what do we notice that all these terms have with them that in common? An x. So we can actually divide that out first. So if I had 3 and I took 1 away, now I have x to the second, or x squared. If I had 2 x's and one of them mysteriously disappeared, now I have 1x. And then got that. Now this is something we can deal a little bit better with. Okay. This we could do the shortcut method on, or AC bus to B, depends on how you operate. Okay. So I know I'm going to have 2 sets of parentheses. I know I'm going to have an x here and an x here. This -5 or this -5 tells us our signs are different. The -4 tells us our bigger number's negative. What are the only factors, or the only 2 numbers that you can multiply to get 5? 5 and 1. So which one's bigger? 5. So that would go here, and 1 would go here. And then it's done. Okay. So here's kind of the deal. In Algebra 1, we would only have like 1 or 2 of these on a test of like 8 problem or 16 problems, okay? This is a whole section of just those type problems, okay? So it's a little bit more, and I got to move my face, okay? All right, let's look at number C. Number C. All right, as we look at them, what do we see that they all have in common? They have a Z. What else do they have? A 5. You could actually divide all these by 5. Now, yes, with the Z's, and I know some of y'all are wishing you were catching some Z's right now. What is the smallest exponent of Z? 2. So that's what we're going to divide out. Okay. So we have 5Z squared we're dividing out. So the 5's cancel. Okay, good. We get 1. If I have 4 Z's and I take 2 Z's away, how many Z's do I have? 2. So Z squared. Okay. 30 divided by 5 is 6. Yes, I'm hearing it somewhere. Okay. And then if I have 3 Z's and I take 2 away, and I have 1 Z. All right. Plus 45 divided by 5 is 9. And the Z's cancel here. All right. So all I did is I found first what was the number that all of them could be divided by, which was 5, and then I looked at the variable. Okay. Think about it. It's like the Venn diagram stuff. This GCF concept, this is how a lot of those dating websites actually work. If you listen to the commercials, it says that you're compared and matched on like 16 or 11 different things. They actually match things that you have in common. That's the greatest common factor. Okay, because they take an inventory of, they give you, I don't know, 30 plus questions. It's been a while since I've used a dating app. Okay. Yeah, because I'm married. Yeah, I'm sorry for everybody. I am taken. Now, shh. Now, all right. So this plus 9 tells us that the signs are the same. This tells us they're both positive. Okay. Now, what are the factors of 9? What 2 numbers we multiply to get 9, but we add them and we get 6? 3. Now, sometimes like in my class, if you were to leave it as this, I'm going to count it. Other times, some other teachers or standardized tests, they would actually rewrite this as this, where they actually say, well, that's the same thing times itself, so it's squared. Okay? So that's kind of how that would work. Now, either one of these would work. Yes. All right. This sign, the sign in front of our C term, tells us if the signs are the same or different. If it's positive, they're the same. If it's negative, they're different. The B term tells us if they're the same, they're both negative or positive. And if they are different, this tells us if our bigger number is negative or positive. Okay. And that's one of those little things that really catches everybody. A lot of people get the numbers right. The signs are the hardest part for some people because it's a very small, detailed thing, and it's one of those you have to practice it, practice it, practice it. All right. Now, are we good to move on to the next slide? We still got people writing stuff down. Yeah. I've actually seen more people take notes today than they ever have. It's crazy. A lot less people have popped up from their phone saying, I don't understand what was going on because I wasn't looking. I may have made eye contact with a student that habitually does that. And it's even funnier because they're still on their phone as they're laughing hysterically and turning as red as the stop oxygen theft sign. Okay. Now, they're taking those invisible notes. All right. So, now, we hadn't done a lot with cubes, okay, in the past, but cubes are when it's to the third power, not ice cubes, not Roblox. But have we ever done the sum or difference of two cubes? As it states on your notes, the sum of two cubes, look, the sum of two cubes, a cubed plus b cubed. We haven't done that before. Okay, we've done the sum of two squares, we've done the difference of two squares. Now we have this, and all it is, you have to plug stuff into a pattern. Okay, now, against my better judgment, I actually let y'all see how this works out. Okay, so now let's look at this one right here. We've done A. I forgot to do B, but we'll fix that. All right, so now this has our example right here that we're doing. All right, we kind of have to write this as what would be it cubed. Okay, so what do you cube to get x cubed? Okay, x. Wow. The whole class went, Okay, so what number, when you cube it, do you get 125? Or what is the cube root of 125? Yep, 5. Okay, so I got a typo here. My bad. So this isn't supposed to be a plus. This is supposed to be a minus right here. And this is supposed to be a plus right here. Sorry. Okay. Now, So now we have to, this is our A, this is our B right here. So we have to say x minus 5 goes right here. Okay. Then we would say x squared plus, okay, this is be our A. This right here, this little squiggle, this is an A. Shh. And the reason it's an A is because I'm going off this up here. Now, this would be, yeah, I made a typo, so we've got to fix that. All right, and then 5 would go here, and then we have 5 squared, okay? Or you don't have to put the parentheses, so let me take these out. So this is a 5 squared. All right, now from this, we just simplify. So we leave the x minus 5, how it is, times, well, x squared is just x squared, plus, what's 5 times x? 5x. What's 5 squared? 25. And we're done. That is, yes. Yep. Yeah, it's, I I accidentally had a typo. It's supposed to be a minus right here and a plus right here. All right. Shh. Now, I know I had the B on there. The B wasn't supposed to be covered because I don't think I had it on the handout. Let me double check. No, I didn't. That was not supposed to be up there. So y'all mark out the B. We could do it if you want to. Y'all want to? This one right here, the 16s to the fifth plus 54s squared. Is it not is this not on your handout? No, this. It is on your handout. All right. So I know there's no setup, so we can do it anyways. All right. So let's do this. Let's shift fire and adjust. So let's do this. Send to new page. Oh, and I can go back. And let's grab this. Oh, that's right in my ear. All right, and send to the current page. All right, perfect. So Control X and Control V. All right, so this is what we're working with. Okay, it's a sum because there's a plus between them. All right, now, yes. All right, so we have to think about this. I would suggest the first thing we do is factor out a 2s squared. Let's do that. Okay, there's a reason why. Okay, because I'm seeing something y'all aren't. Okay, so if we divide 2s squared right here, all right, so then we would have 2s squared. This would be, oh no, that messed up. Yes. So this would be 8s to the third plus 27. All right. The reason why in this, we can rewrite 8 as 2s to the third power, and we can rewrite 27 as 3 to the third power. Okay? So this would be my A. This would be my B. No, we're not doing the back. I forgot to put the setup for this one in. Yes. I'm like 5 minutes in this problem. Somebody's like, "Where are we?" I'm kind of thankful that this microphone does not pick up everything that is said in my classroom, because though it might get me more subscribers, because they were really like, "We want to watch the video that teacher," God, crazy, because his students drive him nuts. Shh. This is what I wonder. I still would love to know if teachers or other people are watching these videos as actual, help for subjects. Cause, oh yeah, that would be hilarious. They're like, "Oh, I'm going to be out. Just go to Schoology, click on this link, and it's my face." All right. Where there are multiple S's on the multiple, it's a S. The only 5 up here is this right here. Well, I'm sorry that you finally looked up from your phone. You don't have to be mean because you're not paying attention. All right. So, let's kind of fill this out. We're going to have 2s squared right here. Shh. All right. So, I'm going to fill this in. My 2s goes here. My 3 goes here. Okay. My 2s goes here. I'm raising it to the second power. 2s, 3, and then 3 squared. Now, here's the deal. I'm going to try to not give y'all one like this where you got to do the GCF and then this too. Oh, if you look, all I did was plug in into this formula. All right, and now I'll just clean it up. 2s squared. I know somebody's going to say that S looks like a 5. All right, this would become 4s squared minus 6s plus 9. Okay, now all that said and done that's this. Now, here's the deal. This would be almost like a bonus type question. Okay. I would prefer, look, y'all go right here. Ready? Take your writing utensil and put a star or something right here, because this is more like I would want y'all to do. Okay. I just covered this because some people may wanted to have figured it out. you know, it's hard to take notes with Cheeto dust on your hands. So, all right. So, now we have a different example. This is basically taking something to the fourth power and acting like we're squaring it. Okay. So, if we look at our original problem right here, okay, so we have this. Come here, come here. Oh, there we go. All right, so here's our problem. We can rewrite this as, nope, there we go, as this, which looks like the difference of two squares, right? Which that means that it's going to look more like this. Now, we're almost done with this one. Almost. Okay. This part right here, we can't factor anymore. So we're going to leave it. All right. But this is actually a difference of two squares. What's the square root of 4? 2. Whew, thank goodness somebody answered that one. What is the square root of 9? And we're done. So here's the big thing about this. It's actually knowing how to rewrite it to get to where we are. Here's the bad thing about that. Due to COVID and virtual learning and stuff like that, factoring is a very big Achilles heel, pain in the side. It's one of those things that not a whole lot of people remember or grasp or got. Okay. So I'm going to take this, as well as we can. I'm going to check something right quick before we move on. Oh, perfect. All right. Let's look at this. What is the square root of 16? Okay. If I have 4 n's and I take 2 of them away, what do I have? Okay, so we can say this is 4n squared to the quantity squared. Quantity. It is. Now, what is the square root of 625? Yeah, 25. That's why we have calculators. I even had to do it on my calculator. I didn't know. All right. So we can rewrite this as 4n squared plus 25 times 4n squared minus 25. Okay. Now, this part right here, we can't factor this anymore. So we leave it alone. I'm thinking y'all need more sit up, fill in the blank type stuff. Okay. Now, on this back end, we can do this as a difference of two squares. All right. So the square root of 4 would be 2. Square root of 25 is 5. All right. So here's the thing. I know we're going through the notes and people are trying to figure it out and struggling stuff. Hang on, I'll come back right to you. This is a good thing about me paying attention. I thought this would work, and I'm seeing that we have more people that need to see stuff more structured where you would actually write stuff in and things like that. Yes, what's your question? Yeah. Yeah. See, used to y'all would have this problem in Algebra 1. Okay. Now we're kind of doing this problem on steroids, basically. Which, yeah, steroids aren't a good thing. Yeah, they're illegal. But it's, you know, it's kind of a hard thing if you, again, forget the basics of the Algebra 1 factoring and try to do this. So that will help me out. All right. Good deal. All right, let's look at this one. So, this is actually the easiest section of the notes that we're doing. I did not say that we're not doing the back at all. Hey, I got you rewind the tape. You asked if we were on the back. I said we are not doing the back right now. I love how y'all are arguing with me about details and y'all don't know what's going on. Okay, so, all right, this is what we have to do. It says determine whether this is a factor of this. So, now, there's another way to do this using synthetic division. But I said, wait a minute, if we're just needing to determine if they're factors or not, we don't need to do synthetic division. So, watch this. Remember how we would put this number in the timeout box? What's the opposite of minus 2? Positive 2. So what we do, we take the opposite of this and we plug it in everywhere we see x for this. So we find f of 2. So plug in 2, plug in 2. This becomes 4. All right. So when you plugged in 2 and you did the math, what did you end up getting as an answer? 4 plus 4 is 8, minus 4, this is 4. All right, here's the deal. It's only a factor if after you plug it in, it's 0. Is this 0? No. So the answer with this would be no, it's not a factor. This has to be 0 for it to be a factor. Why are we doing what? Because, yes, I finished answering one question and I had somebody ask exactly the same question. So, yeah, if it's a factor after you plug it in, it equals 0, so it doesn't. It's not a factor. Yes. Okay, the question was, what does that F mean? I've got to let my filter kick in before I answer it because. All right, so do you see this right here? You see how it says f of x? I'm basically finding the function when x is 2. Okay, so that's what the f means. Shh. Just checking. Well, if you look at this stuff right here, it says first, we use the opposite sign of the binomial. The binomial is x minus 2. So what's the opposite of minus 2? So that's why we use 2. Second, when we plug in 2 for x, that's what this f of 2 means. If it equals 0, then it is a factor. After we did this, did it equal 0? No. So it's not a factor. So we can just say no. All right. Let's try to do another one. Let's try to do another one together before I turn you loose on some on your own. Shh. Now, first, there's this thing that's called directions, and you look at the directions it's asking to match something else. Our directions say now determine whether the binomial is a factor of the polynomial. So that's exactly what we just did. This is the only thing that you're doing on your own today. Okay, so first, everybody, what is the opposite of -4? All right, so we are going to take everywhere we see x and put a 4. Why are we switching it up? It's just a different number. It's not like a new concept. Okay. Well, I gave you space to hopefully do your work. So hence, therefore, the blanks. Now, if you have blanks in your brains after this, that is not my fault. So everywhere I see X, I put a 4. Guess what I can use on this? Calculator. All right. So I think I literally just said it. You can just plug it into your calculator. And somebody just says, do you plug it in your calculator? Look, I just got to be able to grow hair back. Y'all are going to make it fall out. All right. So I put it all in my calculator. It kind of goes all the way across. All right, I'm sorry for my subscribers. I have to stop because I've got to perform massive cranial rectomotomies on my students where I surgically have to remove their head from their butt because they won't pay attention. So, thank you for all my subscribers. And if you haven't, don't forget to subscribe, hit the bell, and hit the like. Good stuff, good things. Roll Tide.